Hello, everyone, and welcome to the webinar, Tackling Infiltration and Inflow with SLiiCER. This is part 3 of this multi-part series, and this is our final webinar in this particular series as well. Today, we'll focus on understanding wet weather flows. My name is Eric Lott. I'm the marketing manager here at ADS, and I'm going to be serving as your host today. Today's presenter is Kevin Enfinger. Kevin is a senior product manager and region engineer at ADS Environmental Services with over 30 years of experience in environmental engineering and consulting. He holds a Bachelor of Science in Chemical Engineering from the University of Florida and is a registered professional engineer. Kevin is a member of the American Society of Civil Engineers and the Water Environment Federation. So thanks, Kevin, for your preparation, all the time and effort you've put into this webinar. And without any further introduction, I'll turn it over to you.
Thank you, Eric, and thank you for all of the attendees that have joined us today. We're certainly happy to have you with us this morning to talk to us about I&I with SLiiCER. So we're going to talk about a tool today that is used to get a handle on I&I in a sewer collection system. So if you're asking yourself, if you're the only one out there that has an I&I problem, just rest assured that you're not alone. I think when we talk to our customers, I&I is one of the most important topics that comes to mind for them. So it's an issue and it has to be addressed. Resolving I&I problems often starts by evaluating how your system's performing. And that insight begins with flow monitor and rainfall monitor data. The rainfall causes the I&I that enters your system through defects and other points, and it is the flow monitor data that tells you how your system is responding to that. So the purpose of this webinar series is to learn how to apply SLiiCER, which is our cloud-based I&I analytics tool, and to learn how to use it to understand and prioritize I&I problems in your wastewater collection system. So this is actually our part 3 webinar. So just as a review, we started back in August with a part 1 webinar called The Big Picture, where we gave an overview of SLiiCER at a rather high level. And then part 2 and 3 are designed to drill in a little bit further. So part 2 was back in September. We talked about understanding dry weather flows, and part 3 is understanding wet weather flows. And I think when it comes to infiltration and inflow, the wet weather component, a lot of people want to jump right into that. But you have to understand the dry weather flows, those base flows in your system first. So that was the order of these. This is the last one in this particular part of this series. I think we will come back next year and maybe do a few more of these webinars on SLiiCER with some more specific features inside of SLiiCER. So stay tuned. There's more to come later next year. So what is SLiiCER? Well, SLiiCER is simply our next generation of I&I analytics tools. It's available in our Prism cloud-hosted web app. And simply put, if I had to distill SLiiCER into one statement, it's a tool that allows you to see, understand, and act on I&I in your sewer system. Some of you may or may not be familiar with our Prism platform. So Prism is our cloud platform where the data from our monitors goes up into the cloud, and at its very basic functionality, Prism is a large data warehouse. I would argue that we probably have the largest repository of flow monitor data of anyone in the world. And for somebody like me, that's a lot of fun. So we have a lot of features inside of Prism that allow us to view that data, export that data, and get insight from that data. SLiiCER is the piece that is focused on the analytics associated with infiltration and inflow. Now, I have shared this graphic in each of the previous 2 webinars, and for those joining us for the first time today, I want to kind of show this graphic again, make sure we're all on the same page. This graphic here shows you pretty much in a nutshell what SLiiCER does and how it goes about it. So if we start at the top of this graphic where you see the rainfall data, the very first thing SLiiCER does for us is it takes time series rainfall data and it parses that rainfall data up into individual rainfall events. So this can become cumbersome to do by hand, but it's fairly straightforward in SLiiCER. In fact, it does all that work for you. But the very first thing we need to know is in an I&I study is when did it rain and how much it rained and what are the properties of those rain events. The next thing, if you look below this rainfall data, you see flow monitor data from a part of a sewer system. And you quickly notice that every time it rains, there is a response in the sewer system. We want to understand what this response is and how different it is from our typical flows when it's not raining. So SLiiCER will go through and pick out what we call the dry day patterns, which is that bottom graph on the left. And it will say, hey, let me find times when it's not raining and when the system is not in a recovery from a previous rain. And let me identify those dry day patterns, that base flow or normal in the sewer system. So you'll notice we have two curves on the bottom left. We have a green curve and a blue curve. Those represent weekdays and weekends. We track those separately because they're distinctly different enough that they can affect your I&I calculations. Once we have that information, we're also able to estimate the split of those dry day flows between what we call wastewater production and base or groundwater infiltration. If you look at this second graph on the bottom, once we have that base pattern from dry weather, we're able to look at each of these individual events. So this third event that you see in the middle, that's the one I have highlighted in the second graph at the bottom. And conceptually, all we're doing is we're taking the actual flow from the flow monitor, and we are overlaying the dry day flow. That's the flow that would have happened had it not rained. And that difference is the rainfall dependent infiltration and inflow, or RDII. Now we can do this not just for this one event like I'm showing, but we can do it for all of these events for all of the basins we're evaluating. Now for this particular location, I can take all of those events and I want to see how they stack up against each other. We call this graph a Q versus I graph. Just think of rainfall on the bottom and I&I on the y-axis here. And the harder it rains or the more it rains, the more I&I you expect to see in the system. And we do see that clearly here. We see this trend. And then eventually we want to do this for all of the basins we're looking at, and we can stack rank them like we see on this graph at the bottom right here. I don't think I've encountered a collection system out there yet where they have told me that they have all of the money they need to tackle all of their I&I problem at once. So there is always a need to prioritize, and this is one of the core functions of SLiiCER, is to help you prioritize which areas of your system are performing the worst in terms of I&I, so you can dedicate your resources there rather than guessing at putting them in other places. So that, in a nutshell, is what SLiiCER does, and I call that the path from data to insight. So on the last Part 2 webinar, we talked about the dry weather piece. I'm not going to focus on that today. We have the video from that webinar you can review and get all the details on that. Today, Part 3, we're going to focus on the wet weather piece, which really focuses around the rainfall and the events that are identified out of the rainfall data and the corresponding impact in the collection system, which is the rainfall dependent infiltration and inflow, or RDII. Now, SLiiCER operates, and you'll see this as we get into the demo a little later. It's broken up into 6 components, and those components are listed here. We have a configuration, we have settings, basins, rainfall, flow, and results. Those are the main functional areas inside of SLiiCER, and wet weather features, as you might expect, are found throughout those. So we're going to look and step through each of these areas and talk about the features in there related to wet weather analysis. So we're going to start with the settings. And I'm going to show you a few screenshots to start here, and then we're going to move to a demo where we will see this in action. But sometimes these static images help explain some of the background concepts before we get into the demo itself. But in the settings, there is one feature in there called a storm event setting that allows us to tell SLiiCER how it goes about calculating the rainfall events. How do we identify them, and how do we determine if they're valid or not for us? And there's really two settings that we operate with. One is called a minimum rainfall threshold, and the other one is called a minimum time between storm events, or the inner event time, some people refer to that as. And these are the two criteria that we use. So the rainfall threshold is an amount at or above which a rainfall event is considered significant. So for example, if you have a small amount of rain that causes no response in your system, we really don't care about analyzing that event. So there's often a certain base level of rainfall that you need before you see some type of significant response. So we use this as a way to eliminate things that really don't need our attention. The inner event time is a period of no rainfall that must be met or exceeded between independent rainfall events. So it almost sounds counterintuitive. I mean, it seems so easy as humans to say, what is a rain event? And you can almost say, well, it rained last night, so that's an event right there. But you have to actually use a couple of parameters like these to parse through a set of rainfall data to pull out what those actual events are. And these settings allow us to do that. So we have a number of default settings that we use inside SLiiCER. And so you start out, if you change nothing, you have a list of ADS defaults. These are default parameters that we have set up over the years that we think are pretty reasonable for most applications. And then you also have the ability to change these settings. So right now, if you're a customer in the United States, you're going to be working in U.S. customary units. If you're outside the U.S., say in Canada, you're going to be working in metric units. These are the default rainfall thresholds that we're going to use. They can be changed at the customer level so that anytime you create a SLiiCER study after that, these settings your custom settings will be used, or you can change them individually for each study you create in SLiiCER. But these are the defaults, and it gives you an idea of how we go about creating these rainfall events. So basically in the United States, we're going to ignore by default anything under a ½ inch of rainfall. Now let's take a look at the Basins tab. The Basins tab is what I call the metadata of an I&I study. So typically when we think of an I&I study, we're thinking about the flow data and the rainfall data, but there's also some additional parameters you need to put that data into perspective. And that is the properties of the basins from which the flow comes that's measured by that flow monitor. And so there's two key parameters here on the Basin tab where you can enter some metadata about the basins. One is the area, which I'm referring to the land area of the basin, and the other is the sewer length. So these values are not required for SLiiCER to run, but they certainly provide additional insight for any type of wet weather analysis. So if you're a U.S. customer or a U.S. project, your land area is going to be in acres. If you're in metric, it's going to be in hectares. Similarly, sewer length is going to be expressed in feet in the U.S., and it's going to be shown in meters in other parts of the world. This information does not come from the flow data, so it comes from your GIS system data. So, for example, if I'm working on an I&I study for a customer, I'm typically requesting this data either from the municipality that owns the sewer system or from a consulting engineer that might be working with them. So this is information that has to be acquired from the GIS and actually imported or put into SLiiCER. Now I want to talk a little bit more about this concept of a flow monitor basin. So I think folks that have been doing I&I work for a long time, this is something that's just understood. But I think if you're new to the I&I business, this is something you have to look at and make sure that you understand, because it's fundamental to what we do. So when we talk about a flow monitor basin, we're talking about a series of sewers that are connected together and collect and convey wastewater to a given flow monitor. So it's everything upstream from that flow monitor. So once you start to look at that geographically, you will see that that basin has certain properties associated with it. So some of these characteristics of those basins can be important for gleaning additional insight out of the flow monitor data that we see. Those may include the land area, the length of sewer. We've talked about those earlier, but you may have other characteristics of those basins that offer insight as well, including the land use of that basin, population, sewer material, sewer age, etc. Now, in addition, we use the term basin in SLiiCER. You may use some other terms. You may hear the term sewer shed, a sub-basin, monitor basin, a meter basin, or catchment is another one. These all mean the exact same thing. It is a collection of sewers upstream that flow down to one common point, and there happens to be a flow monitor at that point. So let's look at this conceptually here. So on the right, I have drawn or noted a flow monitor. It's the green dot labeled FM1. And then I have drawn a basin that I call flow monitor basin 1. So you'll see the flow monitor itself has a location. It's installed in a certain pipe, in a certain manhole, but the flow that it is measuring comes from a much wider area upstream. So that's the idea of a basin. And let's look at one in practice. So you see the white arrow here on the left. There's a line coming in at the 2 o'clock position of this manhole. If we wanted to capture flows at this location, we would be dealing with this flow monitor basin. And you see with the GIS map underneath, there's immediately a number of properties that come to mind. You see that this basin has a certain land area. You see it has a certain length of pipe contained within that basin. There's a certain number of manholes. There's a certain number of houses. We could even correlate that with population or water use data if we would like. So there's a lot of information available here that's important for an I&I study. Now, I want to explain another concept here. Let's take our same flow monitor, this FM1 and this flow monitor basin 1. And let's say I add another flow monitor upstream to break this basin in two. So put another flow monitor there, and that subdivides this larger basin into two smaller basins. So I'm going to go back to the graphic I was on before. So flow monitor 1, the flow that comes out of that monitor measures this whole basin. And this we refer to as the gross flow, or the gross infiltration, or the gross I&I that's measured at that flow monitor. Now, if I subtract out the upstream monitor, I get the net flow associated with this green basin, and I get the net base or groundwater infiltration, and I get the net rainfall dependent infiltration and inflow. So when we talk about basin sizes and land areas, sewer length, in SLiiCER, we're referring to the net basin. That's how you want to pair those together. But you'll see that concept in SLiiCER, gross and net, and with knowledge of this, there's a relationship between flow monitors. In SLiiCER, we're able to do these gross and net calculations for you automatically. Now, how are these basin properties used? Well, they're used to normalize the I&I results that we get out of an I&I study. So if you look at three properties here, we're going to use in SLiiCER. One over here on the left is the I&I volume that we calculate. We have the basin area from some GIS data. We have the rainfall data. and we put that information together, we're able to calculate an R value, or other terms for that may be the capture coefficient or percent rainfall. We're able to calculate that information automatically. Alternatively, if you like to use the sewer length to normalize your I&I results, you can use a different metric, which I've used this quite a bit over the years, where we calculate I&I and represent it in terms of gallons per foot of sewer per inch of rain, or in metric it would be liters of I&I per meter of sewer per millimeter of rain. But this allows us to more effectively compare I&I between basins, and allows us to compare with some benchmarks that we might use as an arbiter of good or bad I&I performance. Now, there's another feature on the Basins tab that I want to talk about briefly. You see it highlighted in green here. This is an area in SLiiCER where you can enter the centroid latitude and longitude, and that is the centroid of the flow monitor basin. So this is not the GPS coordinate of the flow monitor. It's not the GPS coordinate of the rain gauge. It is the centroid of the basin itself. Again, this is not information that's required, but if you do enter it, it allows us to automatically do some more sophisticated rainfall distribution for your basins. So what is a rainfall distribution method? It's a way of taking individual point source rain gauge measurements. And if you think about it, what a rain gauge is doing is it's measuring flow at essentially an 8-inch or a 200 millimeter opening wherever that rain gauge is deployed. And we're using that to extrapolate what's happening over a much, much larger basin area. Well, this can be done with greater confidence if you're using multiple rain gauges and you're weighting the results from those gauges to the different basins. So let's go back to our conceptual basin here. You'll notice I have 3 rain gauges scattered around these 2 basins. So if I wanted to pick the closest rain gauge, well, the closest rain gauge to the center or the centroid of basin 1 is RG1, and the closest one to flow monitor basin 2 is that RG2. I could also do some more sophisticated weightings where I weight the values from these gauges differently based on how far away or how close they are to the center of these basins. So we have 4 available options in SLiiCER to do this type of rainfall distribution. We can select the closest rain gauge. We can do an inverse distance or an inverse distance squared distribution, or you can choose your own. You can have a user-defined distribution. And I can say by default, without any other information, SLiiCER will simply average the rain gauges available to it and will apply that average across all basins. But as soon as you provide the centroid latitude and longitude, the closest or the inverse distance or the inverse distance squared can automatically be set. So that is a very convenient feature. I know in the past I've had to do some of these inverse distance squared calculations myself in the spreadsheet. They can be a little time consuming, and this takes care of that for you. All right, so next we're going to move into the rainfall and the flow and the results. I'm going to show these together, and we're actually going to do this in a live demo. But I also wanted to point out, of these 6 tabs, the configuration and settings and basins tabs, these are really what I call the setup components of a SLiiCER study. So you're not going to spend a lot of time with these in practice. In the basins component, you'll spend enough time there to get the information entered. Where you really do the lion's share of work in SLiiCER is in the rainfall, flow, and results tabs. And so we'll kind of look at those together. So let's walk into SLiiCER here. And I'm going to go into the live production system. And you'll see a notice up there. We actually are doing a update to SLiiCER at the top of the hour. So we'll be done with our demo by then. I'm going to log into Prism. And it's going to take us to this customer that I have set up here called Customer SLiiCER Demo. So this is the main homepage in Prism. SLiiCER resides under this Analytics tab. I'm going to select on SLiiCER. It's going to take us to a SLiiCER dashboard. So SLiiCER allows us to manage different studies. And study is a term that we use, and it's really just meant to be a group of flow monitors, a group of rain gauges for a specified time period. That is a study in SLiiCER. And we can manage anywhere from 0 to many studies in SLiiCER. So if I created more studies, there would be additional rows in this list. But I have one here right now. So I'm going to select this study, and we come into SLiiCER into this particular study. You'll note these 6 tabs that I mentioned earlier: configuration, settings, basins, rainfall, flow, and results. We have that information there. Let me walk through some of the items we touched on earlier. So here in the settings tab, I've got a few options here. Most of them are related to dry day calculations, but I do have one here called storm event. And there you see my minimum rainfall threshold. It's currently set to 1/2 inch. And I've got a minimum time between storm events, which is set to 720 minutes, which is 12 hours. Again, I can change this for this particular study, and SLiiCER will update my calculations. Or I can change these at the customer level. So if I create additional studies after this, it will use my new customer specified default settings. Let's move over to the Basin tab. So the Properties tab that I mentioned earlier, here's that information. You'll notice I have some information entered here for the area of these 3 basins. And I also have a length of sewer assigned to these basins. I've left the footprint column empty at the moment. The footprint is really a way to express in US units, the inch miles of a sewer basin, or in metric, it would be millimeter kilometers. And that's really a parameter that's used to assess groundwater infiltration. We're not going to talk about that in detail here. You'll also notice I have some centroid, latitude, and longitude coordinates that I have entered for these basins that enables me to use the automatic rain gauge distribution methods. So on the rainfall distribution tab, you'll notice here that we are currently set with the inverse distance squared method. So SLiiCER has looked at my rain gauge coordinates, it has looked at my centroid coordinates, and it has done the math and figured out the weighting on these different gauges already. If I want to change this method, I simply just pick a different method here from the table, and it will make that adjustment for me, recalculate that distributed rainfall for each basin. Now, let's go and look at some data. So here's the rainfall tab. And the very first thing that you see, and I'm going to turn one of these features off here. The very first thing that you see is a hyetograph of rain gauge data. So the hyetograph is just a time series of rainfall data. You'll notice at the bottom right, I have 3 rain gauges that are plotted. So there's 3 gauges included in this study, and they're all here by default. So I can turn these on or off. I can look at any combination of these I would like. And as you might expect in any type of graph in any type of web application, I can zoom in, I can zoom out, I can pan left, I can pan right. All of those features are available here. Now, one of the other interesting things, I haven't shown you this in any of the previous webinars, is we have a feature down here at the bottom called block days. What is that? Well, sometimes you might have a rain gauge that was misbehaving on a certain day, and I don't want that data to unduly influence the calculations on my I&I study. So I have the ability to specify that I want to block that gauge from a certain day or certain days so that the data from that gauge is not used. And I'll show you how we would do that. I'm going to zoom in here to this window of time right here. And let's say I wanted to ignore the data from this gauge on this particular day. I would just tell SLiiCER to edit block days, and I come in here and pick a particular day, and you'll notice it's by default now it's saying, hey, you want to block all this day for all three of these gauges. So I can make an adjustment here, and if I apply this change, SLiiCER will ignore the rain data from these gauges that I've highlighted for this particular day. So this is great if you have one gauge that's maybe was not representative of rainfall that day, but the others are. You can just ignore that one gauge for that day. SLiiCER will automatically adjust the rain gauge distribution that it does for that particular day. That's a nice feature to have. Some of the other subtabs you'll notice here are some of the additional rainfall features that we have available. Rainfall events. This is a table showing you the rainfall amount for each rainfall event that's been identified for each rain gauge. And I use this table to take a look at the events to see what the totals were for each event and to see how consistent the rainfall data was across each event. Now, this information is usually fairly easy to get in like a calendar, 24-hour type format, and you can get a report like that in Prism. But oftentimes what you'll find is that these rain events, they will straddle a calendar day, and they will cross into more than one calendar day. And so SLiiCER takes care of all that for you and gives you the totals for the events themselves. The other thing that we have here is the depth, duration, frequency data. So this is rainfall depth, duration, frequency data. What is that? So rainfall depth, duration, frequency is some historical data. It's often available from some government agency. In the United States, it's available from the National Weather Service. In Canada, it's available from Environment Canada. And we have the ability of pulling that data into SLiiCER. And what that does is allows us to compare our current events that we observed in the study with those historical depth, duration, frequency data. Now you see on this rainfall characteristics tab, for each of the rainfall events that we have here, we have calculated the maximum rainfall amounts for different time periods, and we've collated that information here. On the rainfall DDF tab here, we have the rainfall depth, duration, frequency data that we have imported from the National Weather Service. So if you're a US-based customer, all we have to do is upload this National Weather Service frequency estimates. In fact, this is not something you have to do for every study. We do this once in the customer setting, and you never have to think about it again. If you have a different data source than the National Weather Service, we can enter that information, and again, it's a one-time entry. I know, for example, people in the state of Illinois, they have a set of state DDF curves that they use instead of the national curves that are available, and that's fine. We can take those as well. What we do with that is on this graph right here, we're able to plot these different return frequency curves, and we're able to compare individual rain events and see how they line up. So this is my very first rain event in the study. This one's on January 6th. And you'll notice I have all three rain gauges plotted here at the bottom. And the fact that all this data falls below this 1-year curve tells me that this rain event has a return frequency of less than 1 year at all durations. I can see that quickly. It's very easy to look at. And basically, this is an ordinary rainfall event. There's nothing special about it. And we kind of use this in two ways. So if you have a rainfall event that's, say a 50-year storm, you expect that your sewer system's going to have some trouble with that. And you can look to that and say, well, that's an obvious reason why we were having trouble. If you're having a lot of trouble with a rain event like this, well, your system's really got some trouble then, if it can't handle something that's less than a 1-year storm. So that's the way we use this, is to put those rainfall events into perspective. So I can change any of these to different events, and I can see how these different events stack up individually. Just like the other graphs, I can turn off some of these individual gauges if I need to see some clarity on one gauge or another. That information is there. The other item we have down here at the bottom is the max return frequency. So this gives me a summary of what the return frequencies are, and you can quickly scan through this table here and see that I have none of these rainfall events ever get above a 1-year return frequency. So these are all pretty typical rainfall events for this particular study. And sometimes you're at the mercy of Mother Nature as to what you see during a given study period. We're always hoping for that big 2-year or 5-year or 10-year storm, but you do the math and the probabilities, and they're not as likely. We're often looking at more storms that are of this nature. But this allows you to put those events into context. So that's the rainfall tab. Let's take a look at the next tab here. This is the flow tab. This is probably the most information rich of the tabs that are in SLiiCER. There's a lot of information here, and we'll kind of step through it a piece at a time. So the very first thing that we have up at the top, again, let me strip some of this information off. I call this the main hydrograph in the flow tab. And by default, it's showing me the flow data from the beginning of the study period all the way to the end of the study period. This particular example study happens to be 4 months worth of data, and that's what you see plotted at one time here. This allows you to kind of see the study period at a glance, and I can look very quickly and see when my rainfall occurred. I can see when my biggest responses occurred in the system. You can see they were back in January. It gives me a good overall picture. The other thing that's plotted on here is rainfall data. And this is where I want you to note, this is not the individual rain gauges. So I don't have rain gauge 1, 2, and 3 all plotted here together. This is where we've taken the rainfall distribution method that we've assigned, and SLiiCER has automatically calculated the rainfall over this basin based on that distribution. So that's what you're looking at here, and that's what is used in the I&I calculations. Now we're also able to show which days have been selected as dry days that are used to determine these dry day curves. We talked about that extensively during the last webinar, so I won't cover that in any more detail today. And then we have the ability to show the rain events that have been selected for analysis. Now you'll notice that the bigger events have been selected here, and there's some smaller events that have not been selected. And we have the ability in SLiiCER to say, hey, if you don't like an event that's been selected, you have the ability to delete or ignore that event. Or if there's one that hasn't been selected that you would like to analyze, we have the ability to add that rainfall event in. And we'll walk through that functionality as well. So that is the main hydrograph. I will say this, if you're familiar with Prism and come in and look at data routinely, Prism is designed to show you the most recent data. So it typically shows you the last week, and then you typically look at other durations like the last month or show me the last 3 months or the last year. SLiiCER is always designed by default to show you the whole study period. So if that study period starts March 16th, that's when the data is going to start, and it's going to show you to the end of your study period. I can zoom in, I can zoom out on these graphs as well. That's not a problem, but we always want to start out with that overall picture and that overall view. Now, the first thing you're going to see on the bottom part of this screen is a few sub-tabs here. They're set to the dry days, and you see this dry day graph here by default. If I want to look at the storm events, which is what we're going to focus on today, I can click on this particular sub-tab. Now you'll notice what happened here when I selected the storm sub-tab is if you look in the main hydrograph, you'll notice that the very first rainfall event is highlighted with this orange box. You'll also note that that first rain event is shaded gray in this storm event table. And that means that this event that we're looking at here in this graph on the bottom left is this first rainfall event. Now, you'll also notice something we call a Q versus I graph, and you'll see that one of these data points is highlighted in yellow. That is this event on the left, which is this event on the top of the main hydrograph, which is this event that's shaded in the storm event table. So the main hydrograph gives you the overall view of what's happening in this particular basin. The storm decomposition hydrograph shows you a close-up view of the particular rain event you're looking at. The Q versus I graph shows you how that rainfall event stacks up with the other rainfall events in this basin. And you can control what you're looking at with this storm event table. I'm going to go, let's go to this event right here. So this is the one that is in early March. I'm going to scroll down to this list here. This is one on March 1st. And let me expand this table. So this is a nice feature here. SLiiCER allows you to look at these two graphs side by side, but I can also expand either graph and look at it on top of the other one. So if you want to see a larger view, you can do that, and then you can get back quickly to the side-by-side view. So let's focus on this storm decomposition hydrograph. That's a bit of a mouthful there. Why do we call it that? Because on this graph, we are decomposing the flow data into its dry and wet weather components to calculate that I&I curve for this event. So this particular graph that we're seeing here in green, this is what we call the gross Q. So this is the total flow rate measured by this flow monitor. Now underneath that, you'll notice we're plotting these bright green and these blue curves right here. And those are the weekday and weekend diurnal patterns that were determined during the dry weather phase. We overlay those data based on what day of the week these dates fall on. So this is a Thursday, this is a Friday, and this is a Saturday and a Sunday, and then we're back to a Monday. So SLiiCER figures that out based on when the rain event started, which curves to put underneath that data. And then the I&I curve, that's this orange curve, that is the difference between the actual flow and the dry day curve, which is the flow that would have been there had it not rained. You also see the rainfall data that caused this, and that information is presented as well. So there's a few other shaded boxes on here. What are they? So in this case, we have these purple shaded areas represent what we call the storm event. So collectively, these pink and purple boxes are in SLiiCER called the storm event. We subdivide that storm event into a storm period, a recovery 1 period, and a recovery 2 period. And these are somewhat arbitrary, but we can have the ability to stretch the length of these. We can compress the length of these down if we would like, based on the response that we see in the sewer system. Now, the other thing that we have here is a gray box. We call this the pre-compensation period. And this is when SLiiCER is making a comparison between what's actually the flow that was actually observed and the estimate of dry day flow before a rain event. If we see a difference here, we will actually make an adjustment to the dry day curves automatically during the storm event so that that difference is not running into your I&I calculations, if you will. So that's done automatically. You also have some control over the duration of this pre-compensation period and the type of pre-compensation that's being done. Now, we also have this Q versus I graph, which you see here, where we take these results from all of the rainfall events for this basin and we plot them together. And you can quickly see here, the more it rains, the more I&I see from the flow monitor coming out of this basin. So each one of these rain events are here. And we also apply a trend line to this. So there's a regression line that's done automatically that allows us to see what this trend is. And oftentimes we're wanting to know or to extrapolate based on this trend line. If I had, say, 2 inches of rainfall, how much I&I is that going to be in this particular part of the system? For that, we have something called a design storm feature. And I have set up a design storm here. I called it a 2-inch storm. And I can turn that on there. And let's apply that. And that tells me for a 2-inch rainfall, based on the data we've seen in this study, I expect to get this amount of I&I for this particular basin. So that's useful information. It allows us to take basins that have had slightly different rainfall amounts that we've observed and kind of put them onto an apples to apples comparison. I'll show you some of the other features that we can do related to wet weather analysis. Let's say I have an event that is maybe an anomaly for one reason or another. So, and I'm just going to use this as an example. This January 12th event is this event right here. So now we've got it highlighted. Let's say that I want to choose to ignore this event for the purpose of this regression line. So I can simply tell SLiiCER to ignore that event, and it's going to exclude it from this particular basin, and it's going to update that regression line for me. And it's not going to eliminate that storm from any of the other basins, but it allows me to do it for this one. I can put that back here, apply that change again. So that is something that's basin specific. If I decide that I don't want that rainfall event at all across any of my basins, for whatever reason, I can come over here and simply delete that event. I'm going to leave it for there for now. I have had some people have some confusion. When you delete an event, it does not mean that you are deleting any flow monitor data. It does not mean that you're deleting any rainfall data. What it means is you're deleting the characterization of that period of time as a rainfall event. So SLiiCER will not do any I&I calculations, and it will throw out its calculations for that period of time. Now, what if I have an event that's not selected, but I would like to look at? And let's pick one of these other little events right here. If for some reason I wanted to look at this little event right here, I can say I would like to add a storm. And I'm going to come in here and zoom in on this first. So this is this particular event right here. I can change this add storm slider to active. And as soon as I hover over this graph, you'll see this vertical line. I can bring it to the start of that rainfall event, and I can click right there, and I can add that storm event. So that's how easy it is to add a new event that has not been automatically identified by SLiiCER. All right, I'm going to move to the Results tab next. And you'll notice on the Results tab, there are a number of sub-tabs. So there's a Dry Day Statistics tab. There's a Dry Day Hydrograph tab. We talked about those extensively last time. The ones related to wet weather are the Storm Event tab and this Basin Q versus I tab. We have this information here. Basically, any parameter that we have calculated can be plotted and can compared. You can exclude basins or include basins. You can exclude or include storm dates. And you can get to all these values right here. So everything we have calculated from peaking factors to I&I volumes to rainfall amounts, it is all here. It can be plotted, it can be sorted, it can be exported. So if you're using this in some other application or wanting to create some additional custom graphics, you can get to that information as well. Same with the Basin Q versus I, all of that information is there, including the projected design storm values and the parameters of those regression lines. They're all available to you. So that's a quick tour through SLiiCER right there. Let me exit out of that application. And let me talk about a few key points to remember here. So SLiiCER is a suite of I&I tools, and it's used to extract valuable insight from flow monitor and rainfall monitor data. So today we focused on the wet weather piece specifically. So SLiiCER allows us to distill that wet weather information from the flow monitor and the rainfall data to support I&I analyses. And in fact, even the name SLiiCER, you notice it has the two I's in SLiiCER, and it is meant as a tool to allow us to slice up the flow monitor data into its dry weather and wet weather components. So SLiiCER is designed with the wastewater professional in mind. And I just want to emphasize that SLiiCER is not a black box. So it's designed with certain default settings that will spit out an answer for you. But at every step along the way, it gives you a graphic to take a look at that and gives you the ability to update and amend those calculations if you so choose. So there are sometimes you need a quick and easy I&I study. Just give me an answer, give it to me fast. SLiiCER can do that. If you need to sharpen your pencil, for example, if you're going to spend a few $1,000,000 on a rehab project in a certain area, you probably want to make sure you take a close look at things and make sure that the calculations that are done have some of your engineering judgment in them. And SLiiCER allows you to do that as well. So it'll do the heavy lifting on the calculations, but it leaves you in control as to what it is calculating. And then sometimes when you see a demo like this, it can be a little overwhelming. Sometimes it makes a little more sense if you look at that demo in the context of your own system and your own data. So if you would like, I'm certainly willing to spend a little time with you and show you some of your own data inside SLiiCER and look at it in that manner. So let us know and we will get in contact with you about that. I want to remind people that all three of these webinars are being, or have been, or are being recorded. So we make those available in our webinar archive. So if you'd like to go back and revisit some of this material, or maybe if you're joining us today for the first time and would like to look at these previous webinars, they are available. I also want to remind people that a few years ago, we actually did a rather detailed webinar series. We called it Infiltration and Inflow Measurement and Methods. This is really about the why of how we do I&I studies. So SLiiCER itself, these webinars have been focused on the how-to by taking a tool like SLiiCER. This other webinar series focuses on some of the details of why we do some of the things the way we do them. And these were put on by a collection of folks here at ADS, and there's a lot of wisdom in these studies. So take a look at that. If you want to learn more about SLiiCER, we have some additional supporting material available on our website, including some videos that are out there to show you how to use SLiiCER. And Eric, with that, I'm going to turn it over to you.
Sounds good, Kevin. Thank you so much for all the great insight, as always. We really appreciate it very much. Let's go ahead and move into our Q&A time. We had a ton of questions that were submitted in advance of the webinar and a bunch of questions that were submitted today. We're going to try and just go through a few of those that were pre-submitted today, but believe me, if you have submitted any question, we promise to answer all of those promptly following the webinar. So Kevin, this first question is, does SLiiCER allow sorting of storm events by antecedent moisture conditions, such as the antecedent precipitation index 30, also known as the API 30 method, or any other method?
So the answer to that is no, not at this time. But I'm the product manager for SLiiCER, so I'm always interested in features that people would like to see in SLiiCER. So I will be reaching out to the person that asked this question to learn a little bit more. But if anybody else out there has any interest in this particular area, just make a note in the chat, and I will reach out to you as well. So, but no, it doesn't at this time. But we're always looking at new options.
Does SLiiCER support pre- and post-rehabilitation analyses for both groundwater infiltration and rainfall-dependent infiltration and inflow?
The answer is yes, it does. So we haven't really shown that feature yet. Probably be in a webinar next year when we'll take a look at that. But SLiiCER has a feature called seasons and another feature called regimes that allows us to subdivide a study period into smaller groups. And the classic example of that is to take a regime, which is just a time period of interest, and we would specify a time period that is associated with pre-rehabilitation flow data, and we would have another regime associated with post-rehabilitation flow data. And all of the analyses that we have shown over the last 2 webinars, all the dry day calculations, all the wet weather calculations, are basically done separately for those 2 regimes, and then you can compare those results. So you can compare the infiltration estimates in dry weather, and you can compare the I&I that you're seeing. For example, those regression curves on the Q versus I graphs, you can draw multiple regression curves and show the ones for the different periods. So yes, you can, and we will show off that feature in greater detail later.
How much rainfall dependent infiltration and inflow is too much?
So there's no standard answer to that. So I know a lot of times when we do an I&I study for folks, they're interested in saying, hey, if it's above this number, it's bad. If it's below that number, is good. And it's not necessarily always the case there. A metric like that is good to use as a benchmark, but it's probably not the only metric you should use. If you're having overflows in your system, your I&I is bad. If you're having surcharges, that's another level of bad. If you're having basement backups, that is also bad. So some of those are just no-brainers there, but you have to keep that in mind. But I often kind of look at 2 different parameters. I often look at how is the system responding to those rainfall events in terms of capacity. If we're seeing surcharging, we're seeing overflows, you may not have a high I&I number, but if your system is already pegged out at capacity, it's going to look like a low I&I number, and you're still having problems. So I will say look at some of those other parameters as well. So I've got a couple of other webinars on those topics. So if you look at part 4 and part 5 of our I&I measurement method series, and there's another one I did called intersections, assessing sewer performance based on sewer design guidelines. So those provide some additional insight on that particular topic. But in summary, there's no single number that says I&I is good or bad. It is relative.
Kevin, we're at the top of the hour, so we're going to make that our last question. Let me wrap it up for us here real quick. We'd love to continue to receive any questions, any comments. We'd love your feedback on these webinars. So if you have anything else on what any other information you need on what Kevin shared with us, please reach out. My email address is on the screen. Make sure that gets to the right person, and we'll follow up with you promptly on those things. Again, thank you for joining us, and this will conclude today's webinar.